We're on to lesson 12 of the organic chemistry series. So this one is about the functional groups carboxylic acids and esters. Right? We can see that they're treated together because they're very similar. This one has a carbon double bonded to an oxygen and single bonded to an oxygen. And then attached to the oxygen is a hydrogen. This one also has a carbon double bonded to an oxygen and single bonded to an oxygen, but rather than a hydrogen, it has a carbon chain, right? So similar to like aldehydes and ketones, like I think, you can either have a hydrogen or you can have a carbon chain, right? Now, this one's interesting because being that it's a carboxylic acid, right? We already talked about acids in the equilibrium unit, right? Carboxylic acids are all weak acids, right? None of them are part of our big six strong acids. And which is the acidic proton, right? That can easily come off of a carboxylic acid? Well, it's this one that's attached to the oxygen, right? And that's because oxygen's being very electronegative, and there's two of them, right? They pull the bonding electrons towards them. So these oxygens are pulling the bonding electrons towards them, which pulls the electrons away from the hydrogen, right? Weakens that OH bond, and that hydrogen now can easily be released as H+, right? So that's always your acidic proton in your carboxylic acid. So now we can look at how we name these, right? Carboxylic acids, right, are going to have the ending ic acid, right, as the ending of the main chain. So I can start drawing my carbon chain, and I'll put in OH, right? OOH, right? So there's my functional group for my carboxylic acid. And same rules as before, the main chain has to include the functional group, and the functional group has to get the lowest number. And a carboxylic acid, as you can see, will always occur at the first carbon of the chain. So again, we won't have, like aldehydes, we won't have to number the functional group in this case. It'll always be number 1. And then we can number the rest. So this has 6 carbons. So we're going to go hex and then rather than an E to make it hexane, right, we're going to put O-ic acid. Right, so carboxylic acids have the ending oic acid. Right, there's no O in carboxylic, right, but there is ic acid, right, so it's in the name, right. So we have hexanoic acid, right, 6 carbon long carboxylic acid. And of course, now that the numbers are there, right, we could throw in a branch, like a methyl group there, and that would be 3-methyl hexanoic acid. Now, esters are interesting in that they actually take their root name from the carboxylic acid, right? So if I had a similar ester, right, to this carboxylic acid, it actually takes its name from the carboxylic acid. So what we do is we first look at what would be the conjugate base that's left after we deprotonate our acid. So we take away H+, which leaves a minus charge, right? So if this were a generic acid HA, I just took away the H, so this would be A-, and there's the minus charge for A-. So this would be our A-, right? So this is the conjugate base of 3-methyl hexanoic acid. So how do we name the conjugate base? It's not an acid anymore. So we can take away the name acid, right? And we take away the ic from ic acid. We leave the O, right? And all we do to name the conjugate base is just add 8, right? So this is now 3-methyl hexanoate. It's the conjugate base of 3-methyl hexanoic acid, right? So kind of like if you have acetic acid, right? What is the conjugate base of acetic acid, right? It's acetate, right? So we added an 8, right? So you take away the ic acid and you put 8, right? And that's how you get the conjugate base of a carboxylic acid. So now that we have 3-methyl hexanoate, this is actually the base of an ester, right? All we have to do in order to make it an ester is now, where we've taken the H away, replace it with a carbon chain, right? So we take away our minus charge and we just add a carbon chain to it, right? This, in this case, is a ethyl carbon chain, right? Then all we do is we add the name of the carbon chain to the beginning of the conjugate base. So our conjugate base here is still 3-methyl hexanoate. And all we're going to do is add the name ethyl to the front of it in order to make it an ester. Right now I haven't left myself enough room here. Right, so again, I'm going to start with the base, the conjugate base, right? And ignore the carbon chain here for a little moment. So that's 3-methyl hexanoate. Hexanoate. Right? Right, and that's the ester part, right? And then what's the carbon chain that goes on the oxygen of our ester? Well, it's ethyl. So it's ethyl 3-methyl hexanoate, and that's how we named this ester. Right? So the naming of an acid, its conjugate base, and the ester are all actually related, right? As well as the structure of carboxylic acids and esters also being related. Right? So it's carboxylic acids and esters.